Sandblasting, or abrasive blasting, involves propelling abrasive materials at high speeds to clean, strip, or surface treat materials. While effective, it poses significant health and safety risks if not properly managed. Key health hazards include silica exposure, which can lead to silicosis, lung cancer, and chronic obstructive pulmonary disease. The OSHA update in 2016 and 2018 reduced the permissible exposure limit to 50 micrograms per cubic meter over an 8-hour shift and requires employers to implement engineering controls and provide respirators if exposure exceeds limits. Other respiratory hazards include toxic dust from metals like lead and cadmium, as well as asbestos when blasting older structures. Noise-induced hearing loss is another concern, as blasting equipment generates noise levels between 110 and 140 decibels, exceeding safe limits. Ergonomic injuries can occur due to repetitive motions and heavy equipment use, leading to musculoskeletal disorders. Safety hazards include high-pressure risks from misdirected blast nozzles, which can cause severe injuries, and equipment failures like burst hoses. There are also fire and explosion risks from combustible dust in confined spaces and electrical hazards when using blasting equipment near live circuits. Visibility issues arise from dust clouds, increasing the risk of collisions or falls, and confined spaces pose risks of entrapment or toxic atmosphere exposure. Personal protective equipment is crucial. Respiratory protection includes supplied air respirators or powered air purifying respirators with HEPA filters, along with emergency escape breathing devices for confined spaces. Protective clothing should consist of abrasion-resistant suits, gloves, and steel-toe boots. Eye and face protection should include full-face respirators or blast hoods with anti-fog lenses, and hearing protection should involve double protection in high-noise zones. Safety precautions and best practices involve using engineering controls like wet abrasive blasting to suppress dust and installing ventilation systems and dust collection units. Training should be OSHA compliant for workers and supervisors, including hazard communication for chemical risks. Workplace controls should isolate blasting areas with barriers and warning signs, and a job safety analysis should be conducted before starting. Substituting abrasives with safer alternatives can also reduce risks. Specialized applications and hazards include dry ice blasting, which poses risks of static discharge if not properly grounded, and sandblasting wood or truck frames, which can release toxic fumes from paints. Ice blasting insulators can create slip hazards from melting ice, necessitating proper drainage. Regulatory compliance is essential, with OSHA standards outlining abrasive blasting equipment requirements and silica exposure regulations. The MSHA and HSE also have regulations for dust control and hazardous substance management. Case studies highlight risks in dam construction and the dangers of DIY sandblasting by untrained users. New trends include automated blasting robots to reduce human exposure and real-time dust monitoring with IoT sensors. Final recommendations for employers include conducting regular air quality monitoring and health screenings, providing NIOSH-certified respirators, and enforcing PPE use. Workers should report unsafe conditions and participate in annual silica training and fit testing for respirators. The key takeaway is that sandblasting hazards are preventable with proper controls, PPE, and training, and staying updated on OSHA and MSHA regulations is crucial to protect workers and avoid costly penalties.